Hi all, welcome to the section Introduction to Apache Spark. Let's talk about the objectives. In this lecture we will talk about what is Apache Spark and Apache Spark components. What is Apache Spark? Apache Spark is a powerful open source processing engine which is built around speed, ease of use and sophisticated analytics. We can also say that Apache Spark is a unified analytics engine for large-scale data processing. Apache Spark is primarily written in Scala programming language and it provides support for Java, Scala, Python and R language. So what leads to Spark trending? The first thing is speed. Apache Spark is engineered from the bottom up for performance. Spark can be 100 times faster than Apache Hadoop for large-scale data processing by exploiting in-memory computing and other optimizations. It's multi-language support. Spark is polyglot, so we can write a program in multiple languages, for example Scala, Java, Python and R. Ease of development. Apache Spark offers simple APIs in Python, Java, Scala and SQL and rich built-in libraries. Unified stack. Part of what has made Apache Spark so popular is its ease of use and ability to unify complex data workflows. Spark comes packaged with numerous libraries including support for SQL queries, streaming data, machine learning and graph processing. These standard libraries increase developer productivity and enable teams to build robust data workflows with a single engine. Deployment flexibility. So we have multiple options to deploy Spark applications. We can use Spark's own standalone cluster manager. We can use Hadoop Yarn, yet another resource negotiator, or we can use Apache Mesos for deployment. So deployment flexibility is also there. Now let's talk about Spark components. The core component is Spark Core, which is the main processing engine in Apache Spark. Apart from being a processing engine, it also provides utility and architecture to other components. On top of Spark Core, we have Spark SQL, Spark Streaming, MLlib for machine learning library, and GraphX. So let's talk about each one of them. What is Spark Core? Spark Core is the base engine for large-scale parallel and distributed data processing. Spark Core contains the basic functionality of Spark, that is, memory management and fault recovery, scheduling, distributing and monitoring the jobs and tasks on the cluster, interacting with the storage systems. Also, Spark Core is home to the API that defines resilient distributed dataset, which are Spark's main programming abstraction. Now, Spark SQL. Spark SQL is a package for working with structured data. It allows querying data via SQL as well as Apache Hive variant of SQL, which is called Hive query language. It supports many sources of data, including Hive tables, parquet, JSON, AVRO, ORC, and many more. Spark SQL allows developers to intermix SQL queries with the programmatic data manipulation supported by RDD, all within a single application. That means combining SQL with complex analytics. Next component is Spark Streaming. Spark Streaming is an extension of the core Spark API that enables scalable, high throughput, fault tolerant stream processing of the live data streams, or you can say real-time data. Data can be ingested from multiple sources, for example Kafka, Flume, and can be processed with high-level functions like map, reduce, reduced by key and window, join, and finally the processed data can be pushed out to the file systems, databases, or live dashboards. Spark Streaming receives the live input data streams and divides the data into batches, which is called D streams, which are then processed by Spark's engine to generate the final stream of results and batches. So the input data stream is converted into D stream. The next component is Spark MLlib. MLlib is a machine learning library that provides various algorithms designed to scale out on a cluster for classification, clustering, collaborative filtering, and many more. These algorithms also work with streaming data such as linear regression or k-means clustering. The next component is GraphX. GraphX is a library for manipulating graphs, for example, a social network's friend graph, and performing graph parallel computations. It extends the Spark RDD API, allowing us to create a directed graph with arbitrary properties attached to each vertex and edge. GraphX also provides various operators for manipulating graphs and also provides a library for common graph algorithms, for example, PageRank algorithm. Now let's summarize. Apache Spark is a powerful open source processing engine which is built around speed, ease of use, and sophisticated analytics. It is 10 to 100 times faster than Hadoop MapReduce. Spark core is complemented by a set of powerful higher level libraries, and they are Spark SQL, Spark Streaming, Machine Learning Library, and GraphX. Spark can use Yarn, Mesos, and Apache Spark standalone as a cluster manager. Spark is a polyglot, that is, it supports Scala, Java, Python, and R language. Thank you. Hi all, welcome to the lecture Resilient Distributed Dataset RDD. What are the objectives of this lecture? In this lecture we will understand what is RDD, what are the different ways of creating RDDs, and what are RDD operations. So what is RDD? RDD stands for Resilient Distributed Dataset. RDD is a collection of objects that is distributed across nodes in a cluster. So let's create an RDD here. So we have RDD numbers which contain 10 elements. Spark will partition this RDD and will distribute the data across worker nodes. RDD supports lazy evaluation. So when we call a transformation on top of parent RDD, Spark is just maintaining the lineage. The actual work happens when an action is encountered. This is called lazy evaluation, and this is done for performance optimization and fault tolerance. Once created, RDD is immutable. That is, when a transformation is called on top of RDD, a new RDD is returned. It allows for more effective fault tolerance. RDD can be persisted in memory or on the disk. RDDs provide fault tolerance. RDDs contain lineage graphs to help it rebuild the lost partitions. Only the lost partitions of an RDD needs to be recomputed upon failure, and they can be recomputed in parallel on different nodes without having to roll back the entire app. RDDs also lets a system tolerate the slow nodes by running a backup copy of the troubled task. So let's understand how can we create RDD. RDD can be created in multiple ways. We can create RDD by reading a text file. We can create RDD by in-memory collection, or by calling a transformation on top of existing RDD, or by loading data from a database. So when we create RDD by reading a text file, the file, it can be a file or set of files which may be local or distributed. Spark Context provides a function text file which can be used to create RDD by reading a text file. We can also create RDD by in-memory collection. So Spark Context create a function parallelize which can be used to create RDD from in-memory collection. We can also create RDD by calling a transformation on top of existing RDD. So for example, we are calling a map transformation on old RDD, which in turn returns new RDD. We can also create RDD by loading data from a database. So we can load data from a Cassandra table and it will return an RDD. So these are the ways to create RDDs in Spark. Let's talk about RDD operations. RDD supports two types of operations, transformations and actions. Now, what is the difference between them? Transformations, they create new data set from the existing one. So when we call a transformation on top of existing RDD, a new RDD is returned. They are lazy evaluated. That means transformed RDDs are only executed when action runs on it. An example of transformations can be map, flat map, filter, and many more. Let's talk about action. Actual execution happens when an action is encountered. They return a value to the driver program after computation on the dataset. An example of actions may be count, reduce, collect, and many more. So let's summarize. RDD stands for Resilient Distributed Datasets, which is a fundamental data structure of Spark. RDD is a collection of objects that is distributed across the nodes in the cluster. RDD supports lazy evaluation. RDDs provide fault tolerance. Lost partitions can be recomputed using lineage graphs. RDDs can be persisted in memory or on the disk. RDDs are immutable. RDD can be created by reading a text file from a collection, by calling a transformation on existing RDD, or by loading data from a database. Thank you. Hi all. In this lecture, we will see how to set up a cluster on Google Cloud Platform, GCP. So what are the steps? Step 1 is create account on Google Cloud Platform. Step 2 is create a new project, and step 3 is create a Spark cluster using Dataproc. So open the website cloud.google.com and click on the button Get Started for free. On the next page, select your country, accept to the terms of service, and finally click the link Agree and Continue. On this page, click the button Try for free. So again we have to select our country, accept the terms of service, and finally continue. Click on the button Continue. On the next page, we have to provide customer information. Select account type as individual, tax information, select tax status as registered individual, provide your name, provide your address, and also credit and debit card details. Don't worry, Google will not be charging anything from your account. So when you sign up for the service, you get $300 to spend on GCP over the next 12 months. So fill all the necessary details and submit the page. So guys, we have successfully created an account on Google Cloud Platform. Let us see how to create a new project now. So for that, we have to go to the console. So click on the button, go to console. This is my dashboard. From this dashboard, we have a drop down Spark cluster. Just click the drop down, and from here we can create a new project. Now on this page, provide a project name. So I'm gonna say CCA175 cluster, and then finally click on Create button. If you see the notification panel, our project is getting created in the background. This operation may take few minutes to get completed. Okay, the project has been created. Click the view link. So guys, we have successfully created a new project here. So as you can see, the second step is also done. We have successfully created a new project in Google Cloud Platform. The final step is create a Spark cluster using Dataproc utility. So we have to find Dataproc from the left navigation menu. So let's go and see how to do that. Okay, so from the left navigation menu, find Dataproc and click on clusters. We have to provide some configuration here, but first of all, we have to click on the option Create Cluster. So on this page, first of all, provide your cluster name. So I'm gonna say CCA175 cluster. The next thing that we have to do is cluster mode. So we have to select single node cluster. that is 1 master and 0 worker. Third change is we have to select the machine type. So I'm going to select N1 standard 8, that is 8 virtual core CPU and 30 GB of memory. Click the checkbox enable access to the web interfaces and go to advanced option because we have to change the image as well. In CCA 175 we have to work with Spark 2.4. So we have to change the image here, Dataproc image. Now the first option says Hadoop 2.10 Spark 2.4 and click this. Okay, finally leave all other options as it is and click on the create button. So the cluster is getting created in the background. Again, this operation may take few minutes to complete. So guys, what is happening in the background? A virtual machine is getting created and I'll tell you how to access the virtual machine as well. Now open the cluster. So these are the cluster details. As you can see, several tabs here. This tab is the monitoring tab in which we can see yarn memory and yarn pending memory. But as of now, we have to go to VM instances tab. Now, this is the virtual machine that was getting created in the background when we created our cluster. And on the right, you can see SSH link, which can be used to open the console. We will do that in upcoming sections. So guys, the third step is also done. We have created a Spark cluster using Dataproc successfully. Thank you. Hi all, in this lecture I'll tell you how to do data setup on Google Cloud platform. So we have 4 steps. Step 1 is to create a bucket in GCP, then uploading the dataset files to the bucket, then mounting the bucket as a file system, and finally put the files to HDFS. So we will be looking into each and every step one by one. So let's open the Google Cloud Console. From the left navigation menu, we have to find the storage option. So let's find it. It's always good to pin the storage to the top. Now open the storage. On this page, we will get an option to create a new bucket. So let's create a new bucket now. Okay, so we have to provide the bucket name. So I'm gonna say cc-175-practice-bucket, and I'll be leaving all other properties as it is, all other configurations as it is, and just click on the create button. This will create a bucket. After creating a bucket, we will be uploading the files to the bucket. So I have got a folder on my machine. I'll be uploading that using upload folder. Okay. So this is the folder on my machine. Just click on upload. This operation may take few minutes to complete, depending upon the size of data. So it is done. So guys, we have completed 2 steps. We have created a bucket and we have uploaded data files into the bucket as well. Let us see how to mount the bucket as a file system. So we have to follow some steps here. First of all, we have to install GCS Fuse. So in the Cloud Console, go to the virtual machine instances page and open the SSH console of the virtual machine that we created earlier. After opening the SSH console, we have to execute few commands to install GCS Fuse. I have already documented the commands and the same is available in the course itself. So you have to download the document and you just have to copy and paste the commands in SSH console. These commands will install GCS Fuse. Now, second step, we have to execute the below command in SSH console. We have to create a directory. After creating a directory, we will mount our bucket to the directory. Third step, after doing that, we will put the entire data to HDFS using HDFS dfs-put command. So let's see all this in the lab itself. So guys, this is the bucket that we have created. Just go back and we can see the bucket details. Now this is my bucket that we have created. You can copy the name. Okay. Now go to the navigation menu and go back to data proc clusters because we have to open SSH consoles. Click on the cluster name. Now go to virtual machine instances tab. Now here you can see SSH. Click on SSH. This will open a new SSH console. Okay, so this is our SSH console. Now we will be executing all the steps one by one here. So first of all, we will be installing GCS views. So what exactly you have to do? You have to copy and paste the commands here. So after installation of GCS views, as we can see, it is done. We have to create a directory, and after creating a directory, we have to mount the bucket to this directory. Again, it's just a copy and paste of commands. So as we can see, that file system has been successfully mounted. Now we can see all the files here, whatever files we uploaded to the bucket. So just go to retail DB dataset and we will be able to see a retail DB directory here. Now if you go inside the retail DB directory, we should be able to see all the data, all the practice data, as you can see here. So guys, we have successfully mounted the bucket as a file system. Final step will be uploading the entire data to HDFS. So let us first of all see what there is in HDFS. Okay, so this is the directory. These are the directories that are present in HDFS, and we will be uploading our dataset to user Spark directory. And the command that we will be using is hdfs dfs-put. Okay, so first of all, let's create a directory dataset in HDFS under the directory /user/spark. After creating this new directory, we will be uploading entire retail DB directory and the data to this HDFS directory. And the command is hdfs dfs-put is the command. Okay. Using this command, we will be uploading the entire retail DB dataset to HDFS. After doing that, we will also be validating the same. Okay, the command has run successfully. Let's validate. So let's copy the data HDFS location, and now we have to execute a command hdfs dfs-ls and provide the path. We should be able to see all the files here. Now we can see a folder retail DB which is created just now, and then under retail DB we should be able to see all the subdirectories related to our practice data. So guys, we have successfully set up the data on GCP. Thank you. Hi all. In this lecture, we will talk about data frame abstraction and Spark. Let's talk about the objectives. I'll tell you what is data frame abstraction. Then we will get to know about Spark SQL architecture. We will be talking about SparkSession, and then we will be talking about data frame reader and data frame writer. So what is a data frame? Data frame was introduced in Spark 1.3. It's a single abstraction for representing structured data in Spark. Data frame is a distributed collection of rows organized into named columns. It's like a relational table in RDBMS, but with richer optimizations under the hood. Unlike RDDs, data frame keeps track of its schema. So we can also say that data frame is equivalent to RDD plus schema. It supports various relational operations that lead to more optimized execution, and it happens with the help of Catalyst Optimizer, which is used internally by Spark. So let's talk about architecture of Spark SQL. So we may be having data in variety of file formats. We may be having data in CSV format, or we may be having data in JSON format or parquet format. Spark SQL architecture provides a component called Data Source API. Data Source API has the capability to read data from a variety of file formats. On top of Data Source API, we have Dataframe API. Dataframe API converts the data which was read through Data Source API into named columns. On top of Dataframe API, we have Dataframe DSL to query the data. We can also use Spark SQL or Hive query language to query the data. This is all about architecture of Spark SQL. Let's talk about SparkSession. SparkSession is the entry point to Spark SQL. SparkSession provides a method read which returns a data frame reader that can be used to read structured data from multiple sources as a data frame. Data frame provides a method write which returns a data frame writer interface for saving the content of the data frame out into external storage. Let's talk more about data frame reader and data frame writer. Data frame reader is used to load a dataset from external storage system. For example, we want to load a parquet file in Spark which is present at some location. So we will say spark.read.format.load. .format is used to specify the format of the file we want to read, and .load is used to specify the location of the file path. We can also read the same file using spark.read.parquet, providing the file path. This is how we can use a data frame reader. Let's talk about data frame writer. Data frame writer is used to write a dataset to external storage system. Let's say we want to write a parquet file in HDFS at some location. So we will say dataframe.write.format.save. .format is used to specify the format of the file, and .save is used to specify the file path. We can also write the same file using dataframe.write.parquet and providing the file path as a parameter. This is how we can use data frame writer. Now let's summarize. What is a data frame? Data frame is a distributed collection of rows organized into named columns. Data frame keeps track of its schema. So we can say that data frame is equivalent to RDD plus schema. Spark SQL architecture contains the following components. We have data source API, then we have data frame API, and we have data frame DSL to query the data. We can also query the data using Spark SQL or HQL, Hive query language. We have data frame reader which is used to load a dataset from external storage system. And we have data frame writer which is used to write a dataset to external storage system. Thank you. Hi all, in this lecture I'll tell you how to work with CSV data in Spark SQL. Let's talk about the objectives now. In this lecture we will understand what is CSV file format. First of all, we will be reading a CSV data without header, and we will be providing the column names using Spark SQL API. Then we will be reading CSV data with header. After that, we will apply infer schema to the data. We will be inferring the schema from the data itself. Then we will provide explicit schema to the data. Finally, we will be writing the CSV data to HDFS, and we will also learn how to apply data compression. So, what is CSV? A comma-separated values file is a delimited text file that uses a comma to separate the values. Each line of the file is a data record. Each record consists of one or more fields separated by commas. So from our practice data sets, we have categories data in CSV. The schema of categories data is we have three columns. We have category ID, we have category department ID, and we have category name. The data looks like this. So if you see this data, every row is a new record. That means every row is a new category, and the three fields of the data of a row is separated by a comma. Now, how to read a CSV file? We will be using SparkSession object which is available in Spark shell with the name Spark. After that, we will be saying spark.read.format.load, wherein format is used to specify the file format and .load is used to specify the file path. We can also read the data by saying spark.read.csv and then providing the file path. For providing the column names, we can say spark.read.format.load.2df. So this 2df method can be used to specify the column names. We can also provide the column names using the different way, that is spark.read.csv.df and then providing the column names. So guys, let's go to the lab and see. So we have already created a Spark cluster. You can see virtual machine instances tab here. Click the tab. On the right side you can see SSH console, an option to open SSH console. So just open two console here. I have already opened the console on my machine. So this is my first console. On this console I'll be starting Spark shell. So the command to start Spark shell is very simple. Spark-shell. This is the command to start the Spark shell. When we start Spark shell, Spark context and SparkSession is automatically created for us. In the second shell, in the second SSH console, we will see the dataset that we uploaded in the previous lectures. So for that we can use hdfs command. hdfs dfs-ls providing the path, that is /user/spark/dataset. Inside dataset we created a directory retail db. This is the location where we uploaded all the data. So this is our practice dataset. Here we can see lot many information, but I'm only interested in the path itself. So what I'll do is, in the same command I'll be using a pipe operator, then awk, and then I'll be saying just print the file path. So it's at 8th location, so I'll be saying $8. Okay. So guys, now it's in readable format. So these are the directories that we uploaded to HDFS using HDFS dfs-put command in the previous lecture. Okay. Now this categories data is CSV data. So we will be reading this data using Spark shell. Let's go back to Spark shell now. This is my Spark shell. Okay. As I told you earlier that when we start Spark shell, Spark context and SparkSession is automatically created for us, and these are the two objects. So this object Spark is of type SparkSession. Okay. Let me clear the screen first. To clear the screen, you can press Ctrl and L key together. Let me go back to HDFS console and copy the categories path here. Now let's read CSV data without header. So category df category data frame is equal to spark.read.format. So we have to specify the format as CSV dot load. Inside load we have to provide the path. So this is my complete path that I have already copied. This will return a data frame, category data frame. Now to see the content of the data frame, you can say cat df dot show. By default show will return top 20 records, but I'm interested in top 5 records only, so I'll provide a parameter 5 here. These are the top 5 records. So we are able to read CSV data using Spark SQL. If you see here, the column names are underscore C0, underscore C1, underscore C2. Now I'll tell you how to provide the meaningful column names here. Before that, we can read the data we can also read the data in a different way, saying, well, cat df is equal to spark.read.csv. We don't have to specify .format .load. We can simply say spark.read.csv, providing the path here. I'm going to copy the path and providing the path here. This will also return the data frame. So we can say cat df.show, give me 5 records. It will give top 5 records. So these are the two different ways of reading CSV data in Spark. So I'll be using the second way of reading the data, that is spark.read.csv. Now let's see how to provide the column names. So I'll suggest you to copy this command and paste it in text editor while giving certification. That will really help you. So I'll be copying this command and I'll be pasting it in a text editor, so that I can just change different options here, copy the command and paste it in the shell and execute. This will save a lot of time. Okay, so when we say we have to provide the column names, what we can do is, in the older command itself, I can say dot to df, and inside 2df we can provide the column names. For example, the first column is category ID. The second column is category department ID. Category department ID. And the third column is category name. Okay. Now let's do a show on cat df. So we are able to provide the column names now. Column names look logical now. Category ID, category department ID and category name. So this is how we can provide the column names. We can also select specific columns while doing a show. So we can say, let's say if you are only interested in category ID and category name, so we can say cat df dot select, and inside select we can pass, okay, just show me category ID and category name. I'm not interested in category department ID. Category name and dot show, give me the top 5 records. So this time this data frame will only show you 2 columns, category ID and category name. So guys, now let's understand how to read CSV file which already contains a header. Let me clear the screen first of all. So we will be copying the dataset path which contains a header. Now we have categories -header dataset. In this dataset, in this CSV dataset, we have a header also. So let's go back to the Spark shell. Let's try to read it in the similar way. Well, cat df is equal to spark.read.csv and just providing the path with no additional configuration. Okay, data frame has been returned. Let's see how the data looks like. So show me 5 records. Okay, have you noticed something here? The column names are still underscore C0, underscore C1 and so on. So what Spark has done, it has considered the header as a data itself. So we have to tell Spark that the first row in the data is a header. So ignore it. Don't consider the first row as a part of data itself. So for doing that, what we have to do is, we have to provide an option. So, well, cat df is equal to spark.read.option, And inside option we have to provide that in this data we have header, so we have to provide header true, and then simply provide the path. I have already copied the path. Okay, this has returned cat df. Now doing cat df dot show and just give me 5 records, top 5 records. Let's see. This time Spark has considered the first row as a header itself, and we can see that. So this is the way to read a CSV file which contains a header. Okay. Now, how to infer the schema? We can also infer the schema. So when this property is set to true, Spark automatically infers the column type based on the data. So we can again provide a new option, infer schema true. So what we can do is, let me copy this command. We will be changing the command in the text editor, and then we will be just pasting it in the Spark shell. So we have dot option header true, and for infer schema we have infer schema true. Okay, dot CSV and then dot CSV. So just copy this command and go back to the shell and paste it. Okay, now we can say, if you want to see the schema now, what you can say is cat df dot print schema. It will print schema of the data frame. So we can clearly see here that the first column is of type integer, the second column category department ID is again of type integer, and the final column is of type string. So this is how we can infer the schema. And when this property is set to true, Spark automatically infers the column types based on the actual data. Now, let's understand how to provide explicit schema. So there may be some scenarios wherein you have to provide explicit schema. For example, you want to change these column names and you want to provide schema. In that case, we can use struct type and struct field for the same. Okay, so let's see that. So first of all, I'm going to import class here, import org.apache.spark.sql.types. Import everything from here. Or I should rather say import everything in the SQL package. Okay. So let's provide explicit schema. How to do that? Well, my schema, simply a variable, is equal to struct type. So struct type, we have to provide a collection here. So I'll be passing an array here, and inside this collection I have to provide an object of type struct field, one struct field for each of the columns. So we have 3 columns in our data. We will be providing 3 struct fields. Let's see that. First one, struct field. The first parameter is the field name. Let's say category ID. So I'm changing the name to cat ID. The second thing is the type. So integer type. And finally, can it be null, true or false? So you can provide either true or false based on the requirement. Now the second field. The second field is again an integer field. Struct field, the field name. Category, department, ID. What is the type? Integer type. And again passing true. Finally, we have category name. So we will be creating a struct field for that as well. So this is cat underscore name, and this is string type, and then can it be null? I'm passing label is equal to true. This is my array and this is my schema, struct type. So guys, we have created a struct type to provide explicit schema to the data. Now let's read the CSV again, but this time passing this schema. So, well, category df is equal to spark dot read dot option, because we have header in the data. So I'm gonna say header true, then dot schema, and I'll be passing the schema that I have created above, dot schema. After that, dot CSV. Inside dot CSV we have to provide the path. So the path is user Spark Dataset retail DB categories header. Now we got a data frame cat df. Now let's do cat df dot show and give me just 5 records, top 5 records. Let's see. So if you see the column names, they are cat id, cat dep id and cat name, because we provided these column names in the struct type and struct field. We can also check the schema. Cat df dot print schema. Okay, so we can see the column name as cat underscore id, type integer, nullable is equal to true. Similarly, cat underscore dep underscore id and cat underscore name. So this is the way to provide explicit schema to the data frame. Now let's understand how to write CSV file to HDFS. So as I told you earlier, we can use the write method of data frame writer to write Spark Dataframe back to HDFS. Let's see that. So our data frame is cat df. Cat df dot show. If I just see top 3 records, this is my data frame. So I'm gonna say cat df dot write dot. We can also say write dot format dot save, and we can also say dot write dot CSV. So I'll simply be saying dot write dot CSV. Inside that I'll be providing the path. So what is my path? My path is /user/ Spark / Dataset. Inside Dataset I'll be creating output. Inside output I'll be saying categories with header. This is my directory. Okay. Now it is done. We are able to save data in CSV format. So let's validate it. So there are different ways to validate the same. We can also copy this path, and what we can do is we can simply read the file here as well. Spark.read.csv, and providing the path, we should be able to see the data. We should be able to see the data here only. Okay, so that means the data has been saved successfully. The other thing that we can do is we can just go back to the different shell that we created, that we opened, and from the shell we can fire a command hdfs dfs-ls, providing the path where we have saved the file. We should be able to see the CSV file here. So if you can see here, this file has been created. Now if you copy the entire path, and we can also see the content as well. How can we see the content? hdfs dfs-tail, and providing the complete path of the CSV file, we should be able to see the data itself. So this is the data that we have in the CSV file. So we have successfully saved a CSV file using Spark SQL. Now, if you have noticed one thing here, our file doesn't contain a header. So how to save a file that contains a header? That's a question. So for that, what we can do is we can say cat df dot write dot option. Inside option, we have to provide header true. That means also save the header while saving the CSV file. So header true. Then now one more thing. Let's execute the command and then we will see what happens. And provide the same path. Okay, the command failed. Why it failed? Because it says that analysis exception, this directory already exists. So you have to provide some more information to Spark whether to overwrite this directory or to append the data. For that we have to specify the mode. Let's see how to specify the mode. In the same command, I'm gonna say dot mode, and my mode is I have to specify save mode dot overwrite the data, and then finally dot CSV and provide the path. Okay, so this time we are able to save the data because we have provided the save mode as overwrite. Let's validate it again. Copy the path. Again, in the similar way, we can say spark.read dot, because we have header this time. So I'll be saying dot option, inside option, header equals to true, and dot CSV, providing the path where we have saved the data, dot show, give me just top 5 records. So guys, this time we have column names as well because we saved the file with header option equals true. Okay. Now let's talk about compression. If you go to HDFS and if you do a tail on top of this file, we can see that the file is plain text file. That means it doesn't contain any compression. We can see the contents as it is. HDFS, DFS, hyphen, tail, and providing the path, we can see the content. But in the real certification exam, the questions problem statement will ask you to compress the data before saving it. So how can we do that? It's very easy. Go back to the shell. Let's say that we want to save the data but in snappy compression. How will we do that? So let's quickly do that. Let's copy the entire command and let's change it in the text editor. That will be easy for us. This is my command. I'm gonna say dot option dot mode dot CSV, and before that I'll say dot option compression, and I want to save data using snappy compression, and then dot CSV. So this time my data should be saved using snappy compression. Instead of providing two options here, we can also use options and provide a map. So just copy the data, copy this command, go back to the shell and paste it. Because we have already given save mode override, so it should be able to overwrite the data. Now let's go back to HDFS. Let's do HDFS DFS-ls on top of the directory and see the file. This time, if you notice, we have got .csv .snappy extension because we have saved the data using snappy compression. Are we able to see the content of the file? Let's validate. HDFS DFS hyphen tail and provide the path. This time we are not able to read the data. It's not plain because we have applied compression on top of it. So this is how we can apply compression on top of data before saving it. So guys, we are done with CSV file format. Thank you. Hi all. In this lecture we will be working with AVRO data. Let's talk about the objectives. In this lecture we will understand what is AVRO file format. So we will understand how to read AVRO file using Spark API. Then we will be writing data in HDFS using AVRO file format, and we will also be applying data compression. Let's talk about AVRO. What is AVRO? Apache AVRO is a language neutral data serialization system. Apache AVRO has a schema-based system and schemas are defined in JSON. A language-independent schema is associated with its read and write operations. AVRO creates binary structured format that is both compressible and splittable, and this is the reason why AVRO is very efficient in terms of speed and storage. Now, let's understand how to load AVRO packages in Spark shell. AVRO packages can be loaded while starting the Spark shell. We can provide the relevant AVRO packages using --packages command. In CCA 175 certification exam, AVRO packages are already loaded in Spark shell. In our practice data set, we have products data which is in AVRO format, and this is the schema of the data. We have product ID, product category ID, we have product name, product description, product price, and product image. So let's go to the lab now. So guys, now I'll be starting Spark shell and I'll be providing the AVRO packages that needs to be loaded. As you can see here, I have used --packages and I have specified the AVRO packages to load. So this will load all the required packages that we want to read and write AVRO data using Spark. Our Spark shell has been started. Now let's talk about the data that we want to read. So we have products data which is in AVRO file format, products_AVRO. Let's go to the Spark shell and read it. So we will be saying, well, product data frame is equal to spark.read.format, and inside format we will be providing AVRO dot load, and then we will be providing the file path here. So guys, we are able to read the AVRO data. Let's do a show on product df. Product df dot show and just give me 5 records. So this is my products data. So this is how we can read AVRO file format using Spark API. Let's apply some filter operation on top of this data. Okay, so what I'm going to do is I'm going to say, well, filtered data is equal to prod df dot filter. So let's say I'm only interested in the records, the products wherein product price is greater than 1000. Let's see. So I'll be saying prod df dot filter and give me only the records where product price is greater than 1000. Okay, so we got some records. Let's see them. I'm gonna clear the screen now. Filtered data dot show and just show me 5 records. So as you can see here, the product price column, all the prices are greater than 1000. Now I'm gonna save this data back to HDFS using AVRO file format. But before that, I will be applying compression on top of it. So let's say we want to save this data using snappy compression. So for that, I'll be saying this is my filtered data dot write dot format. I want to write this data in AVRO format, so I'll be specifying AVRO here. Then I have to apply compression as well. For that, I'll say dot option. Inside option, I will be saying compression and save the data in snappy format. Then after that, dot save. And let's save the data at location user Spark Dataset output products AVRO snappy. So data has been saved using snappy compression and AVRO file format. Let's go and validate. So we will be copying the path. Let's go and let's do hdfs dfs -ls and provide the path, hdfs path. So we can see that our data is in AVRO format, but we will not be able to read the data using hdfs dfs -tail command. To read the data or to see the schema of the data, we need AVRO tools jar. So what you can do is you can download AVRO tools from Maven repository and then upload that jar to the bucket that we created in the previous lectures. Once you upload the jar to the bucket, the jar will automatically be available here. Because we have already mounted the bucket as a file system. So I have already copied the jar in util directory. So we will be going to util directory and we can see the jar here. So this is my avro-tools.jar. Now what I'll be doing is I'll be saying, first of all, let me just copy the path again, the path of the AVRO file that we want to see. So this is my AVRO file. Okay, I'll be saying Hadoop jar avro-tools.jar. Let's say I'm interested in the schema only. Okay, so I'll be saying get schema and get schema for this file which is in AVRO file format and redirect it to, let's say, output.avsc AVRO schema, and let's see. So we have just created a file output.avsc. Let's open the file. Let's do a cat here and let's see. So guys, this is the schema of our data. We have product ID column, we have product category ID, product name, product description, product price and product image. So we can see schema of our data. Now, how to see the meta information? How to see the meta information? How to validate that we have applied snappy compression? For that, what we have to do is we have to say Hadoop jar avro-tools.jar and then here we have to say get meta, providing the file path. If you want to save the data in a file, you can, but what I'm gonna do is I'll be seeing the metadata here only. Now if you see the command output, you can clearly see that avro.kodak is snappy. So that means we have saved our data AVRO file using snappy compression. So guys, in this lecture we have learned how to load AVRO packages in Spark Shell. Then we have understood how to read AVRO file using Spark API, how to apply compression on top of the data, and then how to save a data frame in HDFS using AVRO file format. Thank you. Hi all. In this lecture, we will be working with dates using Spark API. Let's talk about the objectives. We will understand how to convert Unix epoch to a string timestamp using from Unix time function. We will understand how to convert Unix epoch to a date using toDate function. We will extract year, month and day from timestamp value. We will understand how to extract hour, minute and seconds from a timestamp value. And finally, we will be adding current date and current timestamp as a column in the data frame. So let's start. So we have orders data in HDFS and we will be using the same for the demo. So let's read the data, where order df is equal to spark.read.parquet and providing the path. So this is my path. Now this gives me the order df. Order data frame dot show, give me the 5 records. This is my data. But from this data, I'm only interested in the column order underscore date. So what I'm going to do is I'll select this order underscore date column in a new data frame. So where orders is equal to order data frame dot select and just give me order underscore date. That's it. Now let's see. Orders dot show, just give me 5 records. Now in this new data frame orders, we have just one column. This order date column is of long type, which represents the number of seconds from Unix epoch. So by the way, this data is in millisecond. We can use from Unix time function to convert Unix epoch to a string representing the timestamp of that moment. So first of all, we will convert this millisecond into second, and then we will be using the function from Unix time on top of it. Let's see that. So let's add a new column in this data frame, which is timestamp. So I'll be saying orders is equal to orders dot with column, and my new column is order underscore ts, and the value is from Unix time, and providing the existing column name, that is order underscore date, and dividing it by 1000 because I have to convert the data into seconds. This is my orders data. So I'm going to say orders dot show and just give me 5 records. So guys, we have converted the data into a timestamp. We have added a new column which contains the timestamp, date and time. Now what if we are only interested in the date portion? We can do that using toDate function. So to underscore date function returns the date part of a timestamp, and the return type is a date, not a string. So let's see the schema of this data frame first. Orders dot print schema. So we can see that the timestamp is in string. So from Unix time function returns a string as an output. Now let's see how we can add only date. So I'm going to say orders is equal to orders dot with column, and in this with column I'm going to add a new column, that is order underscore dt, order date. And what I have to do now is I have to use toDate along with from Unix time. So to underscore date, toDate works on top of this, the output of from Unix time. So from Unix time, and our column is order underscore date, divide the value by 1000. So this is my orders data frame containing a new column order underscore dt. Let's see that. Show, just give me 5 records. Now we have added a new column which contains the date portion of timestamp. Let's see the schema again. Print schema. So we can see here that order underscore ts is in string, but order underscore dt is a date value, is a date. Now let's understand how to extract year, month and day of the month. So orders is equal to orders dot with column, and in this with column I'll say I have to add a new column year, and the value will be, we can use a function here and we can simply pass the column order underscore ts. So it will extract the year from the timestamp. Now on top of this I will again call with column, and again I want to add month. For that I can use a function which is called month, and again I'll be passing order underscore ts. So let's add day of month as well. To add day of month, I'm gonna say let's say the column name is day and the value is day of month, and day of month is extracted from the column order underscore ts. Okay, so we are done. Let's see. orders.show and just give me 5 records. So guys, we can see that we have extracted year, month and day from the timestamp. We can also extract hour, minute and second. How to do that? Let's see now. So orders is equal to orders dot with column, and let's say the new column that we want to add is hour, and the value is, we can use the function hour and then we can simply provide the column name order underscore ts. Okay, and then I'll be adding a new column, and the name of the new column will be, let's say, minutes. Okay, and the value will be, we'll be using the function minute, and we will be passing the column order date, order underscore ts. Let's add another column. Let's say the column name is seconds and the value is second, and let me pass order underscore ts. Okay, so we are done. Let's see that. Orders.show and give me 5 records. So guys, we have successfully added hour, minute and second column in the data frame, extracting the value from an existing column which is a timestamp order underscore ts. So this is how we can extract month, day, year, hour, minutes and seconds. Now let's add a new column with current date. How can we do that? Let's see. Orders is equal to orders dot with column, and now adding a new column, that is, let's say, current date, cur underscore dt, and the value is simply the function current date. That's it. Current underscore date function. This will add a new column with the current date. Similarly, we can also add a new column with current timestamp. Let's add current timestamp as well. So I'm going to say with column, and the column name will be current cur underscore ts, and the value will be, let's call a function current timestamp. That's it. Okay, so we are done. Let's see. Orders dot show, and let's take top 5 records. So guys, as you can see that we have successfully added the current date and current timestamp. Okay. Now current timestamp data is truncated. If you want to see the full data, you can say dot show 5 comma false. It will show you the complete data without truncating. So guys, in this lecture we have learned how to use from Unix time function to convert Unix epoch to a string representing the timestamp. We have learned how to use toDate function, and then we have learned how to use year, month, day, hour, minute and second functions. We have learned how to add a new column with the current date and also how to add a new column with the current timestamp. Thank you. Hi all. In this lecture we will be manipulating strings with Spark Dataframes. Let's talk about the objectives. We will understand the basic string functions. We will understand how to concat two string values using concatws function. We will understand how to convert a string value into uppercase or lowercase. We will understand how to replace all substrings of a specified pattern with a new value. We will understand how to use split function to split a string value in an array. And we will understand how to substring a string value. So let's start. So let's read customer's data. Well, customer is equal to spark.read.json, and let's provide the path. So this is my path. So this is my customer data frame. Okay, let's see some of the data. Customer.show and just give me 5 records. Great. So let's see, we have customer underscore f name and customer underscore l name. So let's see how can we use concat underscore ws function to concat multiple strings into one. Let's see. So we can say, so in my customer data frame, I'll say dot select, and inside dot select, we can say concat ws, first of all, providing the separator or delimiter, in our case it is space, and then my columns. So my first column is customer underscore f name, and the second column is customer underscore l name. And let's do a show on top of that. Just give me 5 records. So we can see that we're able to concat 2 string columns into just one using concat ws function. Now the column name doesn't look nice, so what we can do is we can also provide an alias. For example, I can say that my column name should be customer underscore name, and this time see the difference. So now this looks good. Our column name is customer underscore name. So this is how we can use concat ws function. Now let's see how can we convert a string value into uppercase and lowercase. So we can use the two functions upper and lower. Let's see that. Customer data frame dot select. Now let's convert the value into lowercase. So I can use a lower function providing the column name. So my column name is, let's say, customer underscore f name, and then I'll be providing alias and let's say first name. Finally I'll be saying dot show and just give me 5 records. So this is how we can convert the data into lowercase. Let's see how can we convert the value, string value, into uppercase. So in the same expression, in the above expression, I'm going to change the function name from lower to upper, and this time the first name should be converted into all uppercase. We can see that. Okay, so let's understand how to replace all substring of a specified pattern with a new value. So let's say we have, let's see the data first, customer dot show and give me 5 records. Okay, so let's convert this data. We have the zip code wherein we have a pattern 78521. So let's replace this 785 with some other value. For example, so I'm gonna say customer dot select, and inside select I can call a function regex p underscore replace, and what I have to provide is I have to provide customer zip code. Customer zip code, and the second value is the pattern I want to replace. So I want to replace 785 with a new value which is, let's say, 999. Okay, and let's give a meaningful name to the column. So let's say zip code, and let's do a show on top of this. So just give me 5 records. So guys, we can see that this 785 pattern is replaced by 999. So this is how we can replace all substring of a specified pattern with a new value using regex p underscore replace function. So let's see how to split a column value into an array. For example, let's say we have street data, customer street. Let's look into the data. Customer df dot select, and just show me the data for the column customer underscore street, and Just give me 5 records. So this is how the data looks like, containing multiple words, 6303 space header space plaza. So what I'm gonna do is I'm gonna split the data into an array, and then I'll be fetching the first word from that array. Okay, so let's do that. So I'll be saying customer df dot select. Inside select, I'll be using a split function, and in split function, I'll be providing the column name. So my column name is customer underscore street. Okay. After that, I'll have to provide space because the data is separated by space. Now, this will return an array, but I'm only interested in the first word, that is in our first row 6303. So I'm going to say get item 0. And finally, I'll be giving a meaningful name to this column. So I'm going to say street name, just street name, and then doing a show on top of it. Just give me 5 records. Okay, so guys, we are able to split the data every row into an array, and then we are able to fetch the first element of the array. So this is how we can use split function to split a string value in a data frame. Let's see how to substring a data. So we have customer data. Let's see the first name. So I'm going to say customer underscore f name dot show, and just give me 5 records. Okay, so what we are going to do now is I'm only interested in the first 4 characters of the first name. For that, I can use substring function. So what I'll say is I'll say customer df dot select, and then using a substring function here. Substring function, the first thing I'll providing is the column name itself, customer f name, and then after that I'll be providing that I want data from position 0 to position 4. So it will return position 0, 1, 2, 3, that is 4 characters. And then I'm going to provide a logical name here, a meaningful name. So I'm going to say simply name and dot show. Just show me 5 records. So guys, we can say that now we are able to substring the data, and it is only returning the first 4 characters of the customer first name. So in this lecture, we have learned how to use concat ws function to concat multiple input columns together into a single string column using a given separator. We have learned how to use the function upper and lower to convert a value into uppercase or lowercase. We have understood how to replace all substring of a specified pattern with a new value using regexp underscore replace function. We have understood how to split the string value into an array, and we have also learned about the substring function. Thank you. In this lecture, we will be working with data frame columns. So let's talk about the objectives. In this lecture, we will understand how to add a new column in a data frame. We will understand how to convert the data type of existing column. We will be changing value of an existing column. We will be renaming a column, and we will understand how to drop a column from a data frame. So let's start. Okay, so this is my Spark shell, and I'm gonna read customers data which is in CSV format. So I'll be saying, because we have header present in the data, so I'm gonna say header true dot CSV, and then I'll be providing the complete path. And my path is user Spark Dataset retail DB and customers. Okay, so this is my data frame. We can see the data using show, and just give me 5 records. So guys, we are able to read the customer CSV data. Now Let's start from dropping a column. So there are some columns, for example, customer email, customer password, which doesn't contain a valid data. So I'm gonna drop them. So let's understand how to drop a column from a data frame. Customer data frame is equal to customer data frame dot drop. We can use dot drop API, and then here we can provide comma separated strings. So we can say customer email, and the second column is customer password, and I also want to drop another column which is customer street. So these are the three columns that I want to drop. Okay, we are done. Let's see the data frame. Customer data frame dot show and give me 5 records. So guys, we can see that now in this new data frame we don't have 3 columns: customer email, customer password, and customer street. So this is how we can drop columns from a data frame. Now let's understand how to add a new column in a data frame. So first of all, we will be adding a new column with a literal value. For example, I'm gonna clear the screen now. Customer df is equal to customer df dot with column. We can use with column API. The first argument is the name of the column. So I want to add a new column with the name country, and I want to add a literal value here. So I'll be passing lit, and I want to add country like USA. Now we are done. Let's see the data frame. Customer df dot show and give me 5 records. We should be able to see a new column now. As we can see, we have a new column country with the value USA. So this is how we can add a new column with a literal value. Now let's understand how to add a new column which is derived from the existing columns. So we have 2 columns here, customer first name and customer last name. I want to add a new column, customer name, with the values from customer first name and customer last name separated by space, and then I'll be dropping customer first name and customer last name column. So let's do that. So I can say customer data frame is equal to customer data frame dot with column, and inside with column we can say I want to add a new column which is customer name, and the value is, now I want to concat the values from the 2 columns. So I'll be saying concat ws. We can use this function concat ws, concat with separator, and the first argument is the separator itself. My separator is space. The second thing is we have to provide the column name. So I'll be saying my column is customer f name, and the second column is customer L name, and we are done. So let's see the data now. Dot show, give me 5 records. So guys, we can see that we have added a new column customer name in the data frame, and the value is derived from the existing columns customer underscore f name and customer underscore L name. Now I'm going to drop these 2 columns. So I'll be saying customer df dot drop and providing the names, and providing the names like customer f name, L name. Now let's see the data frame dot show. See, so we have added a new column customer underscore name, which is basically a derived column. Its value was derived from the column customer underscore f name and customer underscore L name, and we have dropped the other 2 columns, f name and L name. So this is how we can add a new column which is derived from some existing columns of data frame. Now let's understand how to change the data type of an existing column. So for that, first of all, we will do a print schema. Customer data frame dot print schema. Let's see the schema. Now we can see here that customer zip code is of type string. It should be integer. So what we will be doing is we will be changing the data type of an existing column. Let's see how can we do that. Customer df is equal to customer df dot with column, and in with column we will be providing the column name. So my column name is customer zip code. This is my column, and what I want to do is I want to change the type. So what I'll be saying is I'll be saying column call, and inside call I'll be providing the name of the column, which is customer zip code, and I'll be saying dot cast this column into integer type. So let's specify integer here. Okay, we are done. So let's see the schema again. Customer df dot print schema. So if you see the schema again, we can clearly see that customer zip code is now an integer column. Now let's understand how to change the value of an existing column. Before that, let's see our data frame. So we have customer df dot show. Let's see the data, and we are interested in 5 records. So this is my data frame. Now what I'm going to do is we have this column country which contains the data USA. So I'll be changing this data, existing data, to US. So how to do that? How to change the value of an existing column? We can say customer df is equal to customer df dot with column, and we can provide, the first thing is we will be providing the column name, and the second thing is we will be saying call country dot substring 0 to 2. That is, we just want to take the first 2 characters of the country, and we are done. Let's see the data again. Customer df dot show, and just providing 5 as an argument. So we want to see 5 records. So we can clearly see here that the data has been changed. So this is how we can change the value of an existing column. Now let's understand how to rename a column. So in the same data frame, we can see that we have a pattern of column names. For example, we are starting column names with customer underscore state. So we will be changing the country column name to customer underscore country. Let's see how can we do that. Okay. So we will be saying customer df is equal to customer df dot with column renamed. This is the API that we are going to use now, and the first value is the existing column name. So we have country, and the next is the column that we want to rename, the new value. So that is customer underscore country. Okay, and we are done. So let's see the data again. Customer df dot show, and give me top 5 records. Now from this output we can see that the column has been renamed to customer underscore country. Okay. So guys, in this lecture we have learned how to drop a column from a Spark data frame. We have learned how to add a new column with a literal value, and also how to add a new column which is derived from the existing columns. Now we know how to change the data type of an existing column and change the value of an existing column also. We can also rename a column name using with column renamed. Thank you. Hi all. In this lecture, we will be working with Hive Metastore. Let's see the objectives now. In this lecture, we will learn how to read a Hive table in Spark. So we will be creating a new table in Hive Metastore using Save as Table API. Then we will be creating a partition table in Hive using Save as Table API. We will be creating a new table using Create Table command. And finally, we will be writing data in Hive table in overwrite mode and in append mode. So let's go to the lab and see. So let's open Hive shell in GCP. So to open Hive shell, type Hive and press enter. So this is my Hive shell and we are in default database. Let's see the table. To see the tables, we can fire a command show tables. So in default database, we have categories parquet, categories partition, and so many tables. And we have orders table here. So let's read a Hive table from Spark. So I'll go back to my Spark shell. This is my Spark shell. Let's read the orders table here. So for that, I'll say, well, orders is equal to spark.sql. SparkSession is already enabled with Hive support. So we can simply fire a query, select star from default.orders. This is my query. And now let's see the data. Orders.show and give me 5 records. So this is my orders table. Now let's create a new table in Hive using Save as Table API. For that, we can say orders.write.format, and in format we can specify the format as Hive. Then we can say dot save as table, and then we have to tell that we are trying to save a table in default database, and my table name is, let's say, orders_replica. And we are done. So let's validate. Let's go back to the Hive shell now and let's fire a query show tables. This time we should be able to see a new table here, that is orders_replica. So this is my new table that is created by Save as Table API. Let's see some of the data. For that we can say select star from orders replica limit 10. So this will give me 10 records. Okay, so we are able to see the data as well. Now let's see the metadata related to this table. For that we can fire a query describe formatted and table name. So my table name is orders_replica. So this is my table description, and we can see that we have 4 columns in the table with their respective data types, and the serialization deserialization library is, this is simple, the data is stored using text format. Now let's create a partition table in Hive using the same API. So I'll go back to my Spark shell, and this time I'll be creating a partition table. To create a partition table, we have to turn on a flag for Hive dynamic partitioning. So first of all, let's provide the property spark.SQLContext.setConf, and inside setconf I'll be providing a property hive.exec.dynamic.partition, and the value is true. And the second property I'm going to provide is spark.SQLContext.setConf, and the property name is hive.exec.dynamic.partition.mode, and the value will be non-strict. So these are the 2 properties that I need to set. Now let's save the the same data frame orders, but this time in a partition table. So for that, I'll say orders dot write, which returns a data frame writer dot format. My format is Hive dot partition by. So I'm using partition by, and let's say my partition column is order underscore date. And then finally I'll be calling save as table API, and I'll be specifying the database name, which is default database, and the table name, which is orders underscore partition. And we are done. So let's go to the Hive shell and let's validate. So this is my Hive shell, and I'm gonna fire a query show tables, and this time we should be able to see a table orders underscore partition. This is my table. Let's see the data. Select star from the table orders underscore partition limit 10. So this is my data. I'm also able to see the data. Let's see the table description. For that, I'm gonna fire a query describe formatted and followed by the table name. This is my table, and again I can see that I've got three columns in the table: order ID, order customer ID, and order status, and one other column is there which is order date, and it is the partition column. So this time we are able to create a table in Hive, but the table is a partition table and the partition column is order underscore date. So let's create a new table using create table command. For that, we will be using a create table query. So I'll say Spark.SQL and create table orders underscore parquet. This time I want to save the data in parquet file format. So I'll say create table orders underscore parquet, and my columns will be order ID, which is of type int, order date, which is of type string, order customer ID, which is of type int, and the last column is order status, order underscore status, which is of type string. Okay. This is my create table command, and because we have to save the data in parquet file format, so I'll be saying stored as parquet, and this is my query. Let's execute it. So we have created a table orders underscore parquet, and the data will be stored as a parquet file format. Let's go to the Hive shell and validate the same. So this is my Hive shell. I'm gonna say show tables, and we are able to see the table orders underscore parquet. So let's do describe formatted, and let's provide the table name. And we can clearly see that this time my serialization deserialization library is parquet hive serde. That is, we are able to create a table using create table command, and that will store the data in parquet file format. So let's go and store some data. So again, let's come back to the Spark shell. We already have orders data frame with us. So I'll say orders dot write dot format. Now let's understand how can we write the data in override format and append mode. Sorry, override mode and append mode. So I'll say orders dot write dot format, and my format is Hive dot mode. My mode is overwrite, and finally I'll say save as table. Save as table, and now I'll provide the database and the table name. So my database is default and my table name is orders underscore parquet. We are done. Let's go back to the Hive shell and validate. So let's fire a query. Select star from orders underscore parquet limit 10. We should be able to see some data now. Okay, we are able to see the data. So let's save the data, but this time in append mode. Going back to my Spark shell again. To save data in append mode, we have to use mode as append. So let's count the number of rows in our data. Orders dot count. Okay, so we have 6883 rows in my data frame. I'll say orders dot write dot format, and again my format will be Hive because I want to save data in Hive Metastore, and this time I'll say my mode is append. My mode is append, and then I'll specify my database and table using save as table API, and I'll specify the database as default and the table as orders underscore parquet. Okay, so we are able to save the data again in the same table, but this time in the append mode. So my record count should be double now. So I'll go here in Hive shell and I'll simply fire a query. Select count 1 from orders underscore parquet. And let's see the data count. So this time we can clearly see that the row count is just 2 times. Why? Because we have saved the data in append mode. So in this lecture we have learned how to create a table in Hive using save as table API. Then we have used the same API and we have created a partition table. Then we have created a table in Hive Metastore using create table command. And finally we have saved the data using 2 modes, append mode and overwrite mode. Thank you. Hi all. In this lecture we will be working with JSON data using Spark API. In this lecture we will understand what is a JSON file format. Then we will be reading the JSON file in single line mode. We will understand how to read multi-line JSON. And finally we will be writing JSON file to HDFS. So what is a JSON file format? JSON or JavaScript notation object is a lightweight data interchange format. It is based on subset of the JavaScript programming language standard. In our lab, we have customers JSON data that we will be using in this lecture. This is the scheme of customer data. We have customer ID, first name, last name, email, password, street, city, state and zip code. So let's go to the lab now. So I have already opened the Spark shell and this is another console that I've opened. So we have customer JSON data. Let me just copy the path and go back to Spark shell now. So let's read the JSON file in Spark shell. So this is my customer data equal to spark.read.json is the API and providing the path. This is how we can read JSON data using Spark API. To see the data, we can say customer data.show. This is how the data looks like. Let's say we want to select only few fields here. We are only interested in customer first name and customer last name. So we can say customer data dot select customer first name and customer last name dot show. Now So we can select specific columns from the entire data frame. We have selected customer first name and customer last name from the data frame. So this is how we can work with single line JSON. So if you see the structure of the JSON here, let me just go back to the different shell that we have opened, and this is my JSON data. If I do hdfs dfs -ls to this path and see the content of the actual JSON here, again firing a command hdfs dfs -tail command this time, because we want to see the content of the file. If you see the data, every customer record is in one line. So this is one line and this is one customer record. So this is single line mode, but we may be having a multi-line JSON as well. This is my data, customers, multi-line JSON. Now let's look into the data using the same commands. hdfs dfs -ls, providing the path. This is my JSON file, and now I'm gonna say hdfs dfs -tail, providing the path of JSON file, and see the data. We can clearly see that now one record is in multiple lines. So this is multi-line JSON. So how to read a multi-line JSON using Spark API? Let's go back to the shell and see. Multi-line JSON is equal to spark.read. Let's read it in the same way. I'm not providing any additional configuration here. Let's try to read. What it says corrupt record. You cannot see this data now. If you try to do multi-line JSON dot show, it will give exception. And what is the exception? The exception is, since Spark 2.3, the queries from raw JSON or CSV file are disallowed when the referenced column only contain corrupt record. So we will not be able to see the data now because we are not doing it the right way. What is the right way to read a multi-line JSON? In the same command, I'll say spark.read.option, and inside option I'll provide multi-line true. This is the option that I'm providing now. I'm telling Spark that I want to read a multi-line JSON. Let's see. This time a data frame has been returned and it's not a corrupted data frame. We can see the content. Dot show me 5 records. See, now we are able to read a multi-line JSON using Spark API. Let's see how to save data in HDFS using JSON file format. Let's say we have multi-line JSON with us. We can say dataframe.write JSON, and we can simply provide the path. For example, user Spark Dataset output and multi-line JSON output. So we are able to save a file in HDFS in JSON format. Let's validate. Let's copy the path and go to the different console that we have opened. Here what will I do is I'll say hdfs dfs -ls, providing the path. Now we can see that a JSON file has been created here. To see the content, we can say hdfs dfs -tail, providing this JSON file path now, and see the content. See, we are able to successfully save data in HDFS using JSON file format. Now, let's understand how to apply compression on top of this data. So we have customer data JSON data frame with us. This is our data frame. We will be saving this data frame using compression now. So the data frame dot write dot, we have to provide an option here. The option is compression. and the value is, let's say we want to save data using gzip, and then we have to provide the path. The path is, we can provide the path using .json, and we want to save the data in user Spark Dataset output. So this is the location where I want to save the data. This is my path. Okay. So we are able to save the data frame using gzip compression in JSON format. Let's validate. Copy the path and we will be saying hdfs dfs-ls providing the path. So if you see a file here, the file ends with .gz extension. That means we are able to apply compression on top of the data. Now if you want to see the content of the data, you will not be able to see it. It's not readable now. We can see that hdfs dfs-tail providing this JSON path. Okay. So guys, in this lecture we have learned how to read a JSON using Spark API, how to read JSON in single line mode, how to read a multi-line JSON, and how to write data into HDFS using JSON file format. We have also applied compression on top of the data. Thank you. Hi all, welcome to the lecture working with Parquet data. Let's talk about the objectives. In this lecture, we will understand what is a Parquet file format. We will understand how to read a Parquet file in Spark. Then we will understand how to write a Parquet file in HDFS. We will also be applying data compression. So let's start. What is a Parquet file? Parquet file format is very famous, and it's a free and open source column oriented data storage format of Apache Hadoop ecosystem. It is designed to bring efficiency compared to a row-based files like CSV. It provides efficient data compression and encoding schemes with enhanced performance to handle complex data in bulk. By default, Parquet file format support snappy compression. Spark SQL module provides support for both reading and writing Parquet files that automatically preserves the schema of the original data. Let's go to the lab and see. So this is our Spark shell. We have orders data in Parquet file format. So let's read the orders data. So we'll say, well, orders is equal to spark.read. Spark.read returns a data frame reader. On top of data frame reader, we will say Parquet. Spark.read.parquet providing the file path. This is my file path. So this is my data frame orders. Let's do a show. So give me top 5 records. So guys, we are able to read Parquet file using Spark API. Let's do some operations here. I'm only interested in few columns. I'm only interested in order ID and order status, and only the order status where the value is pending payment. Filtered df is equal to orders.filter, and then I'll say give me the records where the column order status value is pending payment. So this will give me the data wherein the value of order status is pending payment. We can verify that. Filter df dot show, just give me 2 records or 3 records and see. So this data frame only contains the data where order status is equal to pending payment. Now I want to save this data back to HDFS, but I'm only interested in 2 columns, order ID and order status. What I'll say is, well, result is equal to filtered df dot select. Using dot select API, we can tell Spark the columns we are interested in. So I'm interested in order underscore ID, the first column, and I'm interested in order underscore status. Okay. Now we can see the result dot show. Just give me 3 records. If you see the result data frame, it contains only 2 columns, order ID and order status. So let's save this data into HDFS in parquet file format. Let me clear the screen first. So I'm gonna say result.write. Result.write returns a data frame writer. On top of that, I'll be saying parquet. Result.write.parquet and then providing the file path. So I'll be saving the data in user Spark Dataset output order pending payment. Let's say this is the path. Let's try to save the data. Okay, we are able to save the file in HDFS and parquet file formats. Let's validate. Let's go to the different console that we have. In this console, I'm gonna say HDFS DFS-ls providing the path where we have saved the data. We should be able to see a parquet file. So guys, this is my parquet file which has been saved. If you notice something, the data is compressed using snappy compression, which is the default compression for parquet file format. So we will not be able to see the data using HDFS tail command. But what if we want to verify or validate the data? What if we want to see the data? We can use parquet tools. So what you have to do is you have to download the parquet tools jar from Maven repository, and then you have to upload it to your bucket that you created as a part of cluster creation and bucket creation, and then it will become available here because we have already mounted the bucket as a file system. So I have already copied the file here. So we have parquet-tools-1.9.0.jar. Using this jar file, we will be seeing the data. So let's copy the complete path of my parquet file, and I'll be using a command Hadoop jar my parquet tools.jar cat --JSON because I want to see the data in JSON format, providing the complete path of my parquet, and just press enter. Guys, this shows the complete data. So this is how the data looks like. Because we filtered only pending payment, so we are able to see the data clearly using parquet tools.jar. Now, as we have seen that by default snappy compression is applied when we save a file using parquet file format, can we change the compression? Let's go to the Spark shell and see. So let's say I want to save this data but not in snappy compression. I want to change the compression. So let's say we want to save the data in gzip compression, which is based on deflate algorithm. So I'll say result.write result.write.option. Inside option, I'll be specifying my compression as, what is my compression? It's gzip now. Gzip compression. Dot, if you want to overwrite the data, you can say overwrite the data, or I'll save the data in a different location. Dot parquet and providing the path. So let's provide the path now. And this time I'll be saying orders gzip. Let's save the data. Okay, so we are done. Let's validate. Copy the path, go to the other console. We'll be doing HDFS DFS-ls providing the file path. Now, if you notice here, this time my parquet file is using .gz extension. That means this time the data has been compressed using gzip compression. So guys, in this lecture, we have learned how to read a parquet file using Spark API. We have learned how to apply data compression on top of that and save data in HDFS using parquet file format. Thank you. Hi all. In this lecture, we will talk about windowing and analytics functions. In this lecture, we will learn what is a window function, and then we will be writing a window query using over clause. We will be using partition by clause and order by clause in our window query. So what is window functions? Window functions operate on a set of rows and return a single value for each row from the underlying query. The term window describes the set of rows on which the function operates. Now the question is how to differentiate window functions from other analytical and reporting functions. And the answer is over clause. Over clause is used to differentiate between a window function and other analytical functions. The over clause has the following capabilities. First of all, it defines window partitions to form group of rows, which is done by using partition by clause, and then we order the rows within a partition using order by clause. So this is our data that we'll be working with. This data is about product. So we have category name, we have a product name, and we have product price. Every category can contain multiple products and each product has got a product price. We will be working with this data in this lecture. So let's calculate average product price for all the categories by using average window function. So we can write a query like this. Select category name, product price, average of product price, and we will be using a over clause here. And we'll give a name to our column, that is avg underscore price from products view. And this will return an output like this. So in the output we have category name, we have product price, and we have average price for all the products. In this query, we haven't used any partition by clause in my over clause, so my window will contain all the records in the table. Now, if we use average function as a standard set function, it will only return one result for the entire group. So my query will be select average of product price from products. This query will return only one row as an output. So the above query returns one row with the average of all the values in the specified column instead of returning values for each row. And this is the difference between a windowing function and other analytical functions. This is my Spark shell. So let's read the data first of all. For this lecture we have products underscore sample data in HDFS, which is in JSON format. So I'll say, well, prod is equal to spark.read.json, and I will be providing the path here. My path is user Spark Dataset retail underscore db product sample. This is my data. Let's see some of the data now. Prod.show and give me 5 records. This is how the data looks like. We have category name, we have product name, and we have product price. So first of all, let's create or replace a temp view. So I'll say prod.create or replace temp view, and let's provide it a name. Let's say the name is products only. Okay. So let's write a window query here to calculate the average product price. For that, we can write a query spark.sql select category name and select product price, and we have to select average of product price, and we have to use over clause here, over, and let's give it a name avg underscore price. This is my column name, and we have to select this data from the view that we have created, products, and this is my complete query. And let's do a show here, and let's say we are interested in 10 records. So this is my data. This is my final output result of the query. And we can clearly see that we have category name, we have product price, and then we have average price of all the products, because we haven't specified any partition by clause here. So that is why my window contains all the rows which are present in the table. Now if we write the same query using average function, standard set function, then let's see the output. So we can say spark.sql select average of product price avg underscore price from products dot show. And if you see, this query only returns one record. It will only return one result for this entire group. So this is the difference between windowing function and other analytical functions. We can also use partition by and order by clause in a query. Let's see that. So the partition by clause subdivides the window into partitions. The order by clause defines the logical order of the rows within each partition. So that means window function get applied to the rows within each partition and sorts the data within the partition only. Let's see the example. Let's use the same average window function with the partition by clause to determine the average product price for each category now. Let's write a query. So I'll say spark.sql, and because I have to write a query in multiple lines, so I'll be using triple quotes here, and I'll say select category underscore name, product underscore price, and average of product price. Average of product price over, and this time I will say partition by category underscore name. And let's give a name to this column. I'll say avg underscore price. So this time I'm saying partition by category name. So the window will be for every category. And I have to fetch this data from my view products. This is my complete query and dot show and give me 10 records. So here we can see that, let's say we have a category training by sport and the average price is calculated on top of the two rows only, because for category name training by sport we have two products. So here the window is based on the category name. So this shows how we can apply a partition by clause, or how we can use a partition by clause in window query. Let's talk about order by clause now. So let's say we want to sort the data based on the product price in descending order as well. So let's write a query for that. I'll say spark.sql, my query starts, select category underscore name, product underscore price, and average of product price. Over, this time I'll say partition by category name and order by product price in descending order. And let's give this column a name. So I'm gonna say avg underscore price. This is the name. Fetch this data from products. This is my complete query and dot show. Give me 10 records. Let's see the output now. So this is my output. Again, we have category name, we have product price, and we have average price. But this product price is now sorted in descending order. So if we see the category men's golf clubs, we can see that the product price is sorted based on is sorted in descending order. So this is how we can use partition by and group by in a query using window functions. So we are done. Hi all. In this lecture we will talk about ranking window functions. Let's see the objectives. In this lecture we will learn what is ranking window functions, and we will be working with several ranking functions like rank, dense rank and row number. So let's go to the lab and see. Okay, so this is my Spark shell and I have got a dataset products_sample that I'll be reading for this lecture. So let's read the data. Well, prod is equal to spark.read.json because the data is in JSON format and this is the path of the data. So we are able to read the data. Let's register this data frame as a temp view. So I'll say prod dot create or replace temp view, and let's provide a name to this view. Let's say products. Okay. So we have registered the data frame as a temp view. Now all of the ranking functions, they depend on the sort ordering specified by the order by clause of the associated window definition. So rows that are not distinct in the ordering, they are called peers. So let's see some of the data. So let's fire a query Spark.SQL and let's say select star from products, a very simple query, and dot show. So this is my data. Now rows that are not distinct in the ordering. So that is, if we take an example of these two rows and if we see that if we sort the data based on product price, these two rows have got the same value for the column. So these are called peers, and the ranking functions are defined so that they give the same rank to any two peers rows with the next ranking skipped. So for that, let's write a query here, spark.sql, and my query starts. Select category name, select category underscore name, comma, product price, product underscore price, and I want to have a column rank over, and now I'll be specifying partition by category name, category underscore name, and order by product price, product underscore price, and let's name this column as rank. Now we have to fetch this data from the view from products, and this is my query. Query ends here and let's say dot show. So I have used rank function here, and if we see the data, let's look into these two rows. So these two rows have got the same value for the column product price, that is 249.99. So they have got the same rank. So that is, if we have two peers, they will be assigned the same rank and the next rank will be skipped. So that is why if we see the third row here, it has given a rank of 8 and not 7. Let's talk about the dense rank function now. The dense rank function is similar to the rank function. However, the dense rank function does not skip any ranks if there is a tie between the ranks of the preceding records. Let's see that. So let's write a query here, spark.sql, and let's start the query. Select category underscore name, comma, product underscore price, and now the third column I want to add to this data frame is dense underscore rank over partition by category name and order by product price, order by product underscore price, and let's give a name to this column as rank. I want to fetch this data from products view. This is end of my query, and let's do a show. Okay, so we have got the data now. If we see the data here, these two rows have the same value for the column product price. and they have got the same rank. But if we see the next row has got the rank 6 and not 7, because this is the functionality of a dense rank function. It is similar to the rank function, but it does not skip any rank if there is a tie between the ranks of the preceding records. Let's talk about the row number function now. So the row number function determines the ordinal number of the current row within its partition. Each value is ordered within its partition. So let's write a query for that. Spark.SQL, and my query begins. Select category name, product price, and let's add a new column, row number. Row number over partition by category name, and order by product price. And let's give it a name, rank. Fetch this data from the view products, and this is the end of my query dot show. Okay, so this is an example of row number. As we can see that for a partition, row number is provided. Okay, so this function determines the ordinal number of the current row within its partition. Rows with equal values for the order by expressions, they receive different row numbers non-deterministically. So we can see here that these two rows, they have got the same value for the product price column, but still they have different row numbers. So this is all about the function row number. Now in CCA 175 certification, there may be a problem statement like find the best selling product in each category. Now how to solve this problem? Such kind of problem can be solved with the help of ranking functions. So first, assign a rank to each product in a category based on the product price in descending order, and then from the above data, just select the rows where rank is equal to 1. So let's try to solve the problem statement. We have to find the best selling product in each category. So first of all, let's assign a rank to each product price in a category. So I'll say top category is equal to Spark.SQL, and we have to select category name. Let's select the product name as well, product underscore name. Let's select the product price, product underscore price, and let's use dense rank function, dense underscore rank, over partition by category name, partition by category underscore name, because we have to find the best selling product in each category. That is why we are using partition by category name, and order by product underscore price, and in descending order. And let's give this column a name, rank, from the view that we have created, products. So this is end of my query, and done. So let's see some of the data now. Top underscore cat dot show, and give me the data. Okay, so this is my data, and for each category we can see that the data has been sorted in descending order based on the column product price. So from this data frame, if I select only the rows where rank is equal to 1, I will be able to find the best selling product in each category. On top of this data frame, top underscore cat, let's filter the data where rank is equal to 1. Why? Because we are only interested in the top selling product for each category. So this column rank should be equal to 1. And dot select, I'm interested in few columns. So I'm only interested to show category name. The second column I'm interested in is the product name. And the final column is product price, product underscore price. I don't want to show the rank in the output, and dot show. This is my final data, and in this data we have the top selling product for each category. So for training and sport category, this is the top selling product with the price 50. Now the data is truncated here. If you want to see the full data, you can pass show and false. So we can write this query like and select and dot show, and we can simply pass false here. Now we are able to see the complete product name. So we are done. So in this problem statement we have learned about the ranking window functions, and we have seen rank function, dense rank function and row number functions. Thank you. Hi all. In this lecture we will talk about aggregate functions. So let's see the objectives now. In this lecture we will learn what is group by and order by clause, and how can we use group by and order by clause with aggregate functions. So we will be talking about the functions count, max, min, average and sum. So let's go to the lab and see. Okay, this is my Spark shell. So let's first prepare the data. So I'm going to read the product table and categories table from Hive Metastore. So I'll say, well, prod is equal to Spark dot SQL select star from default dot products. And now I'll be reading the category data. So I'll say, well, cat is equal to spark.sql select star from default dot categories. And then I'll be registering prod and cat data frame as a temp view. So what I'll be doing is, I'll be joining products table and categories table. We have registered them as a temp view, and then I'll be creating the final data set, and then we will be working on top of that data set. So I'll say, well, data is equal to spark.sql, and let's write the query. Select star from products P, join categories C on P dot product category ID, which is equal to C dot category ID. This is my query. On top of this query, I'll say I want to drop few columns that are not required. So I'll say dot drop, and there are some columns that I'm going to drop now. Now this is my data frame. So I'll say data dot show and give me 5 records. Now this is the data on which we will be applying the aggregation functions. So we have product ID, we have product name, product price, category ID and category name. Let's create a temp view for this data frame. So I'll say data dot create or replace temp view, and inside temp view let's provide a name. So my name will be products underscore view. This is the data that we have. Now we have products underscore view, and we will be applying aggregation functions on top of this view. So let's see. Let's say we want to calculate number of products in each category. How can we do that? To calculate number of product in each category, we can use a group by clause. Let's see that. I'm going to say, well, result is equal to spark.sql, and now I'll be writing a query. So we have a column category name, and then based on the column I'll be applying a group by clause. So I'll say select category name, and I have to calculate count of all the rows in that category. So I'll be using count function, and then I'll be fetching this data from my products view that we created just above, and I'll be using a group by clause. Group by category underscore name, and this is my complete query. Okay, so we got the result data frame. Let's see some of the data. Result dot show and give me 5 records. Okay, so we can clearly see that we have category name and then we have the total products in each category. So in this example, we have used a group by with count function to calculate the number of products in each category. We use this group by clause to divide the rows of a table into smaller groups, and then we can use the group function to return summary information for each group. So let's see one more example. Let's return the data in descending order based on the count. So this time we have to apply aggregate function, but we have to sort the data in descending order based on the count column. Let's see that. Again, I'll be writing a query. Let's say result val result2 is equal to Spark.SQL, and let's write the query. So select category underscore name, comma, count of 1, and the name of the column is count, from products underscore view. Okay, then I have to use a group by clause. So I'll say group by category underscore name, and we also want to sort the data, so I'll say order by. Now I'll be using an order by clause, and I'll specify the column count because we have to sort the data based on the column count which and in descending order. So I'll specify descending, and this is my final query. Okay, so we got the data frame result2. Let's see the data now. Result2 dot show, and let's see 10 records. Okay, now we can see that in this data frame we have category name and count, but the only difference from the previous example is the count is the data is sorted in descending order based on the column count. So we can clearly see that accessories category has got 72 products, and then trade-in, then electronics, and so on. So this is how we can use group by and order by clause. Okay, let's go one step further. Every category has got multiple products, and each product has a different product price. So let's say the requirement is now for every category I want products with maximum price, minimum price, and average price. So in this data frame, in the final output, I want category name, and then I want minimum price for that category, average price for the category, maximum price for that category, and also we can calculate sum of price for all the products in that category. So let's write a query. Well, result3 is equal to Spark.SQL, and the query starts. Select category underscore name. This is the first column that I want, and then I have to calculate the minimum price for that category. I can use a function min, and the column I'm interested in product underscore price. Let's name this column min underscore price. Now I have to calculate the average price. So I can use a function avg average, and then I can pass the column name product underscore price. And let's name this column avg underscore price. We have to calculate the max of the product price here, and then let's give it a name max underscore price. And finally, let's use a function sum for calculating the total of all product price for a category. So sum of product underscore price, and let's give it a name sum underscore price. So these are the 4 columns that I'm interested in. I want to calculate these columns from the products view, products underscore view, and I have to use a group by clause here. So I'll say group by category name, category underscore name. This is my complete query. So in this query, we have used 4 functions, 4 aggregate functions, min, average, max and sum, and we have done group by using the column category underscore name. This is my full query, and let's see the data. So we got the data frame, result dot show, and let's say show me top 10 records. Okay, my bad, it is result 3 dot show. So I have to say result 3 dot show and give me top 10 records. Okay, so we can clearly see that for a category name, we have the minimum price for that category, we have the average price for that category, and we have got the maximum price for that category. And finally, we have calculated the product price for all the products in that category. So in this scenario, we have used a group by clause stating which column to use to group the rows. So we are done. So in this problem statement, we have learned how to use group by and order by clause, and then how to apply the aggregation functions like count, min, max, average, sum. Okay, so thank you.